So this video is to predict the type of bonding that we might see in a different molecule by using the periodic table and looking at how to predict the charges on ions. Now these might seem like different skills, but we do use the periodic table the same way for both of them. So let's do a quick recap of the periodic table to begin with. So if we have a look at the periodic table, we need to first of all remember where our metals and where our non-metals are. So what we should be able to do is to draw ourselves a nice little line going down here, so just through the middle of the metalloids or the semi-metals. And what I've got on this side, I've got my non-metals, and on this side I've got my metals. We know that most of the periodic table is metals. I've got this one little exception here. So hydrogen is a little bit weird, and sometimes you see it written in the middle of the periodic table on its own. And the reason is that it fits into group 1, but it is usually classed as a non-metal. You don't need to know the reasons why. So let's start off by assuming that you've been asked to look at the bonding or to talk about the bonding in a particular element, a particular compound. What you need to do, if you're not familiar with this compound, you need to have a look at the names of the elements involved. If you're not sure whether they're metals or non-metals, you do have a periodic table always in an exam for you to have a look at. So do have a look. If you find that what you're looking at falls under metals, well, it's obviously really going to be metallic bonding. It's quite rare that you're going to be asked about something that's metallic bonding other than the nature of metallic bonding. What's much more common is you'll be asked to identify whether something is ionic bonding or covalent bonding. So the way that we tell that, if we have two elements that come from our non-metals, so for example, I've got my nitrogen and I've got my oxygen bonding together. So if they are both in non-metals, then I know that I'm going to get covalent. So they're both on the same side of this dividing line, so it's going to be covalent bonding. Now, where it gets a little bit harder is when we're looking at things that are both sides of the line. So if, for example, I'm being asked about sodium chloride, which is a very common one to be asked about, you'll notice that I've circled one metal, that's here, and I've circled one non-metal. If they are on opposite sides of the line, so here they have to cross that line. At that point, when they have to cross the line, we are looking at an ionic compound. Okay, so in this case, we're looking at ionic. If we've crossed the line, then it's ionic. If we haven't crossed the line, it's either metallic or covalent, and if they're not metals, it's not going to be metallic. So here's where we start having to think about the types of ions that are being formed. So if we have a look at our different groups, now you're used to these just being here, they're the transition metals. So if we're looking at GCSE, then all we really need to know is these are transition metals. You will be told the charge on the ion. So for example, you might have Fe in brackets 2. That means that the ion is going to be 2+. You might equally have Fe in brackets 3. It's always in Roman numerals, and that means that it's a 3+ ion. So you don't need to worry about the transition metals. For everything else, though, we do need to think about it. So what's going to really help you here is the group number. So I'm going to do a little bit of annotating here, actually, because we ignore the transition metals. So I'm going to scribble these group numbers out here because I'm not interested in them. And that actually makes 13, that makes that into group 3. 14 becomes group 4, 5, 6, 7. And then this is group 8, but we can also call it group 0 because it is the happy elements. So these are our noble gases. These are the ones that are not going to react with anything because they don't need to lose or gain electrons. They're perfectly stable as they are. So from this point, it helps to imagine that the periodic table can be on a sheet of paper and that you've closed it around in a circle and you've put a little bit of sellotape, so you've joined up this point and this point here. So those two ends have joined up, and therefore we can go forwards, and forwards would be going to our right, so this is going forwards, or we could go backwards, and backwards would be going to our left. And of course both of these are counted from our happy elements in group 8 or group 0, the noble gases. So let's start off looking at group 1. So here I've got my noble gases, that's my group 0. So we're going to ignore these numbers here and imagine that I've got helium here and I've got neon here, etc. So we're now going to have a look at going forwards. Now, when we're going forwards, it's really, really easy. It means we've got too many electrons in the outer shell, so we're going to lose them. So the charge of the ion, all we have to do is to put a plus sign in front of the number. So we've got +1, +2, and here +3. It gets a little bit more complicated when we look at groups 5, 6, and 7. So this is going backwards. So we're following the blue arrow, we're going backwards, and we're gaining electrons here. So we're becoming more negative, we're gaining negative charge. A bit counterintuitive, but it works. So here we need to go from the number 8. So here I'm going to go 7 minus 8, and that gives me -1. Remember, we're going backwards from our 8 from our noble gases. So then I've got my 6 minus 8, and that gives me -2, and my 5 minus 8, and that gives me -3. So we can see how we're getting the charges of the ions going in both directions. Much easier to work out the positive ions than the negative ions, but once you get used to it, it becomes much simpler. And anything in that group is going to have that charge. So if we look at our -2 ions, we look down there, we're going to have that charge, okay? Now, you might be wondering why I've ignored group 4, and that's because it takes too much energy for them to move that many electrons around, and therefore they don't. So when we're looking at group 4, we're looking at covalent or metallic bonding, and that's all that you need to worry about for GCSE level. Now, it might look a little bit complicated, but actually it gets very, very simple when you get used to doing this. So it's really important that you remember that you are allowed to write on the periodic table that you're given in your exams, and you can actually annotate it and add the charges at the top of the columns if that helps you.